Hey guys, so this will be the topic on integration. I did thinking of skipping the topic on differentiation in my current series because I think it's really not much stuff to talk about. Um, yeah, but there is still some key things that you guys should know. So and you guys should take note of. But I just don't feel that there's enough content to make it into one video lah. So let me know what you guys think in the comment section below. Okay, so I will start with integrations. Yep, integrations. Okay, so I'm not here. I believe you guys already learned all the good stuff in school, how to do integration of different technique. Okay, my job here again is to organize your thoughts and to give you insights and make your learning more fun. Okay, inspire you to think differently. Okay, so this is how I categorize the different ways of doing of integrating. Okay, one is basic. Okay, what do I mean by basic? It's like, for example, I ask you to integrate this kind of stuff, integrate this kind of stuff. Um, okay, this is everything that this all of this is you should know. Okay, because you learn how to differentiate and you just reverse it. Okay, then the second one, right, is um, manipulation. Okay, the second one, right, is more complex. Okay, so you see, all these are all the different operation, okay, all different operation, okay. So how to make it more complex, right? There's only a few things in math, okay, plus minus times divide, okay. So if like that plus like that, okay, it is still basic, right? Okay, but if it's say like that and like that, why I say it's still basic, right, is because um integration of an addition can be broken down into integrating them individually and summing up them later lah. Okay, so to me it's still basic. Okay, so I say that math can only be plus minus times divide. Okay, so the times when it's times listen when it's times then it's complex. Okay, for example like this. Okay, um then you cannot just like that no because if you think about it, why it makes it more tricky, right, is that now to get back to here, right, to differentiate and get back to here, it become a product rule. Product rule is something plus something, and it definitely don't look like this. Okay, so when it become a product is where usually students struggle with okay, so yeah, so in dealing with this kind of question, right, there's only two ways of solving. Okay, one way of solving, right, is I call it the f prime x method lah. Okay, how to write this notation not important. Okay, I'm just writing here for uh classification sake. Okay, maybe 5 years ago, 3 years ago, you asked me what is this, I would say I don't know. Okay, just I happen to know after teaching long enough, so it's really not important. I did well in school without knowing this. Okay, yeah, so mix up. I mean, yeah, after you know how to do it the other ways, then you would figure out what this notation need to be lah. So it really isn't that important. Okay. Okay. The other one, right, is by parts. Okay, when I say by parts, right, this thing should come into your mind immediately. Okay, so a lot of students, they like to write it like this, and I think that since you already write it like this already, right, you already make the effort to memorize this, why don't you memorize this instead? Like this whole thing, okay? Because a lot of times I think that students still struggle with which one integrate, which one differentiate. Okay, so this make it more efficient. Okay, yeah, so because trigo and exponential and algebra is very easy to integrate, whereas inverse trigo and logarithm is not integratable in the basic manner. Okay, what I'm trying to say, right, is that you learn how to integrate this one to become 1 over x, you learn how to differentiate non-x to become 1 over x, to differentiate sine inverse x to become 1 over square root 1 minus x squared, etc. Okay, etc. E to the power x to e to the power x. Okay, so you can see that there isn't one right. Okay, differentiate sine x to cosine x. Okay, there isn't one right where over here, over this column, there isn't one that there is a logarithm. Also, there isn't one there is an inverse. Okay, that's why we want to put them as a last one to be processed as integration. In fact, these two right are usually dealt with by differentiation. Okay, so I will go through a few examples with you. Okay, so for example, right, this one 1 over x ln x. Okay, so yeah, because it's not something basic, okay, means most likely is a product. Okay, so your algebra must be good to know how to dissect this thing into a product. Okay, product is something times something. Okay, so the only way to put it as a product is like this: 1 over x times 1 over ln x dx. Okay, so this is the f prime x example. So when you look at a product, first thing you need to do is see the inner, because it's a composite function, okay, so see the inner function, right? Okay, what is it? And do a differentiation in your head and see whether this differentiation in your head, right, appears in and as the other product. Okay, that's the other term of the product. Okay, so for example, okay, I see this as a whole, right? Now I will notice a ln x. Then in my mind, I will have, okay, 1 over x. So this 1 over x is here. So this can be a f prime x question. Okay, so once you think that it's a f prime x question, right? Okay, you can throw the f prime x out and just process the thing that you differentiated. Okay, so now, right, as long as I write this, I know that when I differentiate, later, now if I go through d dx, okay, later my 1 over x will pop up. Okay, that's why I say you can throw this away because it will pop up when you differentiate it. Okay, your only job is to make sure when you differentiate this thing is equals to this thing. Okay, so think of what you need to add to this expression, right? So that when you differentiate, it becomes 1 over ln x. Okay, so maybe you will think that is to a power or something, or maybe you will think that is ln this thing. Okay, so then try to reverse the process again. Okay, do a differentiation again, then you realize this answer. Okay, so that's it for your f prime x kind of style. Okay, so if it is by parts, integrate x sine x dx. Okay, whatever that is here, that you form here, minus integrate. This one is not important. As in, is once you form, like it won't hinder you. Okay, what may hinder you is whether you can integrate or not. Okay, so you should pay attention to okay, there's one of the component, right? You need to reduce the power. Okay, and after you reduce the power, right? Okay, it become more conducive to differentiate here. Okay, so obviously looking at these two, right, we will want to reduce the power of x. That's why this one will be a differentiation, whereas this one will be an integration. Okay, looking at the LIATE, okay, so integrate this one first. So that's okay. Okay, so with this, I will. So I don't really memorize whether UV or whatever lah. Okay, what I will do, right, is whatever that need to be integrate, then I will integrate it. So integrate this one is negative cosine x. Okay, then I will put. Okay, so this is how I remember. Integrate already, then put. Okay, put this. Okay, then after that, whatever you integrate, right, you just put. Okay, so integrate, put, then put, differentiate. That's all I do. Okay, so times 1 dx. So equals to minus x cosine x plus sine x plus c. Okay, so that's it for integration by parts. Yeah, okay. The other thing that I want you guys to take note, right, is okay, so one is basic, right? Okay, second is product. Okay, third is manipulation. Okay, I feel that manipulation really tests your skills in identifying what can be integrated and what cannot be integrated. Okay, generally I will branch this into two umbrella. Okay, algebra and trigo. Let's talk about algebra first. Okay, let's say we have something like this: integrate x squared plus x bracket square dx. Okay, yeah, you could think of, okay, maybe this will work. Okay, but then it kind of shows that your differentiation is not really good. Yeah, because if you differentiate, you should have seen that there will be a product later. Okay, so yeah, it cannot be done by just raw basic integration. Okay, so it's not just your understanding of what can be integrated must be good, but I'm saying, like, okay, if you see this as like this, right, then yeah. But it's also your algebra need to be good. Okay, you need to be able to process that, oh, this is something plus something plus something. Okay. Yeah. So integrating this is doable. Okay, because it's just an addition of basic integral. Okay, so yeah, you need to observe and see what you can do to the expression, and then form out steps in your head to see whether they are the resultant is integratable lah. Okay, especially when you expand already, it become plus plus plus, right? Then all the plus is basic, right? Then it's very doable. Okay, next up, I want to talk about trigo, which is where I think a lot of people have problems. Okay, so let's just look at this. Okay, I want you guys to pause the video and try to spend some time and digest the info this, right? And instead of seeing this as ABC plus minus square as a bunch of letters, okay, I want you guys to just look at where is the plus, where is the times, and where is the square, etc. Okay, so spend some time looking at that. 1, 2, 3, as in, yeah. Until you are ready, then continue the video. Okay, pause. Okay, play. Okay, so after you guys did what I told you to do, I want you guys to observe the right hand side and the left hand side. And tell me which one is the basic integration. Okay, so just now we talked about basic integration is like integrate sine x, right? Or integrate cosine x, right? And it can be a plus, right? Can, yeah, without also can. Okay. So if we look at this identities table, the only thing that can be integratable is all the left hand side. You understand? This is not integratable because something times something. Okay, it's not a basic integration. Okay, this is also not a basic integration. Something times something is also not a basic integration. So try to understand, like, because that's why a lot of students don't know how to use these identities, because they got tricked into always using the left hand side to change from the left hand side to the right hand side. Okay, but given the integrand, right, that we cannot integrate, right, we are supposed to change it to the left hand side. Okay, we should do it the reverse way always, in order for it to be integratable. Okay, so for example, you came across something like this, cosine square x. Okay, what you need to do is to look at the identities equations and have an overarching view of what are the characteristics of each of them. Okay, so very obvious, there's only one that deal with square. Okay, so just by looking at this and this, right, you know that you are trying to go towards this direction, and once you do the manipulation to become cosine square x, right, it's definitely integratable. Okay, yeah, okay, so it's about changing from the right to the left, then integrate, which leads me to the discussion of this thing. Very important, okay, a lot of times I see students do this. They will half p plus q equals to x, and half p minus q equals to 3x. Well, you can do that and find what is p eventually and find what is q eventually. A lot of students will get confused, okay, because they are not good with dealing with 3 algebra and 2 equation. Let's say this x and this x are actual values, right? Then they can process it very well. Okay. Yeah, but if you guys were to do that, right, just know that if you want to make this in terms of x, right, okay, you need to substitute the q away so that just make it into an equation just in terms of p and x. Okay, likewise, make this into substitute the p away, then make this in the equation in terms of just q and x. Simple. Okay, but you don't have to do that, and that is not very efficient. Okay, that's why I keep saying, right, like you need to, math is about having that eye to recognize pattern. What happening here, right, is that there's a half p and there's a half p. Then there's a plus and a minus. So just based on that, right, half p and half p, okay, you should come up with something. You should have some inspiration. Okay, so over here, right, half p and half p give us p, 1p. Okay, so if we add the both terms up, right, we will get p, half p plus half p, half q minus half q. So resultant is p. So if we minus them, right, then the half p and half p will cancel off each other. Then the half q will become plus half q. So it will become q, which is what we want here. Okay, so this P, right, is essentially just half P plus Q plus this thing, where this Q, right, is just the same thing minus this thing. So why am I saying this, right? I'm saying, right, this thing, right, you can just straight away sine x plus 3x minus, sorry, this one is sine cosine. Yeah, so I'm using this. Okay, then after that, half minus sine, minus plus sine x minus 3x. Okay, then I differentiate. Okay, so again, this one is quite obvious. Is can be integrated already lah. If it's still not obvious to you, yeah, you have a lot to. You need to focus on identifying the plus, minus, times, divide, trigo kind of thing. Okay, even though there's a plus here, right? There's only constant, so I still see this as a integrating a plus. Okay, so it should be pretty doable already. Okay, so when dealing with this kind of equation, right, you will tax a lot on your this kind of knowledge, especially this part. Okay, your sine bracket negative x okay, is actually equal to negative sine x. Okay, so if you are not sure with this, I need you to draw the graph of sine x out and play around with the x value and y value. Okay, so for cosine negative x, right, is equals to cosine x. And that's it. Okay, so yeah, that's it for the manipulation of trigo. Okay, and we cover all the three categorization. Okay, the basic integration, the product, under product is either by parts or f prime x. Okay, then the other one is manipulation. Okay, so with that, I hope that the video helped you guys to organize your thoughts and inspire you guys to think of new ways to relearn things. Okay, so if you guys have any other ideas, cool ideas, and do share it below in the comment to benefit others, like how these videos have benefited you if it does. Okay, so with that, we will end the recording for today, and I will see you in the next one. Bye bye.